Hello, my name is Mark Lindsay, and I'm a technical specialist with SMC Electric. This week we are focusing on VFDs, and our topic is reflected wave. What is reflected wave? Well, reflected wave is something that occurs in a variety of applications. Sound waves can reflect, radio waves can reflect, even ocean waves can reflect. You've probably been on a body of water and seen waves that go up against a wall or other object and then bounce back in the opposite direction. If the timing of these reflections is right, you can actually see the returning wave right up on top of the incoming wave and increase its height. This same process can happen with electricity. This kind of reflected wave is a phenomenon that occurs when using variable frequency drives to power a motor. It is caused by the fast rise time of the pulse width modulation that is used to create the drive's output. These pulses are reflected back from the motor, which can combine with the outgoing pulses and effectively double the peak-to-peak voltage. The longer the wires between the drive and motor, the more potential there is for this to become a problem. At a nominal 460 volts AC input to the drive, the bus voltage is 650 volts. This voltage is being used to create the PWM output. So if you double that, you have 1300 volts. This can become an issue with both wire insulation and motor insulation. There are several factors that can play into this, and the maximum allowed cable length varies between drives. It is always a good idea to check the technical data of the VFD to determine if there is potential to have a problem. For Allen Bradley drives, the best source of this information is the wiring and grounding for pulse width modulated or PWM AC drives. Towards the end of this manual, there is an appendix that contains tables for all the Allen Bradley drives. Once you find the table for this drive that you're using, you will need to find the appropriate voltage and horsepower of that drive. You also need to know the frequency of the PWM that you're using. For this example, today we are going to use a 5 horsepower PowerFlex 525 drive. We go to our table, make sure that you're using the table for 480 volts, if that's the voltage that you're powering the drive with. We're in the 520 series, so this would be appropriate for a 525. We come down on our horsepower, the 5 horsepower, and we can see that the frequency of the PWM does not matter at either 2 or 4 kilohertz. So we do not need to pull that information up. For this example, let's assume we're using an older motor which has a 1200 volt insulation rating. So the 1200 volt, we come down to our 5 horsepower, and we can see we can go 40 feet without having any potential for issues. Well, that's not very far. So we go across to the column where we're using a reactor, and at the same 1200 volts, we come down, and now we can go 200 feet without potential for a problem. And if we use a reactor with a deafening resistor, we come down here and we see we can go up to 600 feet now. If you need help figuring out the maximum distance or coming up with a good solution, contact your local drive specialist and we will be happy to assist you. Let SMC help you find a solution that best fits your needs. Contact your local branch or find us online at smcelectric.com. Thank you for your time, and remember, at SMC, our knowledge is your power.